Hello students, welcome. Previously, lesson 30, form 3, topic 2, we were dealing with the last aim of direct titration, which was determining the water of crystallization of the analyte. So today, lesson 31, we are going to proceed to the second type of titration, which is back titration. So we're saying back titration is a method of volumetric analysis used to determine the concentration or amount of a reactant. It involves quantities of the substance being analyzed with the excess amount of suitable reagent whose volume and concentration is known. The quantity of the excess is then measured through titration. And we are saying next, the amount of the reagent that reacted with the analyte is determined by subtracting the excess amount from the alkali. The data is then used to determine the concentration or amount of the analyte. Next, we are going to go and see aims of back titration. Remember, we are done with the aims of direct titration, and even back titration, we have three aims. One, determining the molar mass of the analyte. When we are talking about the molar mass of the analyte, we are dealing with the relative molecular mass, that's the relative molecular mass, RMM, or we are dealing with the relative atomic mass, that's RAM, or relative formula mass, that's RFM. So if you are told to look for the relative atomic mass of an element, you are supposed to first of all get the RFM of the analyte, then get the relative atomic mass of the element or the metal. Next, we are having aim number B, determining the mass in grams of the analyte, and aim number C, we are having determine the percentage purity of the analyte. The general steps or procedure of solving back titration questions. This we have done initially when we are dealing with the direct titration, the general steps or procedures of solving direct titration questions. So here we are going to tackle the steps or the procedures of solving back titration question. So if you know these procedures overhead, that means all the questions of back titration, you are able to do it. Okay, number one. The first step, you are supposed to calculate the number of moles of the alkali solutions. Alkali solution, by using the formula, moles is given by molarity multiplied by volume used, then divided by 1000. Here you are going to get the number of moles of the alkali solution. Then Romeo 2, or number 2, step number 2. You are supposed to write a balanced chemical equation for the reaction between the alkali solution and the acid. Remember, this is just a neutralization reaction. So you're expected to get a salt and also water. Romeo 3, you're supposed to use mole ratio. To using mole ratios between the alkali solution and the acid, calculate the number of moles of the excess acid. So what is this excess acid? Remember, we have said earlier on, you are given three solutions. The first one is you are given a metal or a metal carbonate. The next, you will be given an alkali solution. Then the third, you are given an acid. So what they will tell you first is you take the acid and you react with all the metal because the acid is in excess. So that means the excess acid will be titrated or used to neutralized by the alkali, that alkali solution. So what is the excess acid? It is the one that reacted with the alkali solution. So from here 4, we are told determining the number of moles of the original acid by using the formula moles is equal to molarity times volume used over 1000. So Romeo 5, then we are told determining the number of moles of the acid that reacted with the metal or the metal carbonate by using the formula moles of the acid. By using the formula moles of the acid that reacted with the metal or the carbonate is equal to moles of the original acid minus moles of the excess acid. So if you subtract these two moles, you are going to get the number of moles of the acid that reacted with the metal, if you are dealing with metal, or if you are given a metal, or metal carbonate, if you are given metal carbonate. Then after that, Romeo 6, you are supposed to write the reaction between the acid and the metal, or the acid and the metal carbonate, in case you are given metal carbonate. Then Romeo 7, using the mole ratio between the acid and the metal or the metal carbonate, you are supposed to calculate the number of moles of the metal or the metal carbonate. You are using mole ratio. Then Romeo 8, We are told use the number of moles of the metal or the metal carbonate obtained or in Romeo 7 above to determine the aim of the question. In case you are dealing with maybe determining the molar mass of the analyte, what you are supposed to look, the aim. You have to get, first of all, RFM. How do you get RFM? RFM is given by mass over the moles that you have gotten here, Romeo 7. If you are dealing with maybe the mass in grams of the analyte, how do you get mass? Mass is given moles times RFM. So that means you have already gotten the moles in Romeo 7. Then lastly, aim number C, that's determining the percentage purity of the analyte. You have to get, first of all, the mass of the analyte, that's the metal or the metal carbonate. Then thereafter, do the percentage purity by taking mass divided by the original mass, then multiply by 100, you will get the percentage purity of the analyte. That is the general steps or procedures of solving back titration questions. So students, if you are familiar or you have all these procedures on your fingertips, you are able to tackle all back titration questions.